communication between parallel loops, we can use local variables. However, it has a major disadvantage. If two loops are performed at different frequencies, the race condition occurs. Suppose we would like to generate a sine function in one loop and read the generated data in the other loop. Let's create such a program based on local variables. If two loops operate at the same frequency, data is lost very rarely, and we can see the functions of sinus on both charts. However, what happens if the second loop in which we read the data from the local variable will work at higher frequency? We see that we read the same value several times because the first loop does not keep up in sending us a new generated data. Therefore, the second loop should be stopped until the first loop passes the new generated value. How to do it? This is the notifier, a tool for synchronization of two independent processes. It works in a similar way as a local or global variables. In one place we pass the value to it, and in the second place we read it. However, the operation of the loop in which we read the data from the notifier is suspended until the new appearance of data. Let's create another loop, which will read the data generated by loop 1 using the notifier. Now let's create a reference to notifier using the obtain notifier function. You should connect a variable of the type you want to send to the element data type input. In our case, it will be a double type constant. Now let's pass the generated value to the notifier using the send notification function. Let's go to the third loop and add the wait on notification function, which will wait until the first loop passes the data to notifier. Read the data from notifier and display it on the chart. Let's start the program. We see that even in the case of a much lower frequency of loop 3, we always read the generated data points once. Due to the possibility of synchronizing several loops using notifier, it has been applied in the master-slave design pattern. The mentioned pattern is used when we need to perform some actions in parallel and with different frequencies. The master-slave pattern is built from only one master loop and one or more slave loops. The master loop controls the operation of the slave loop and communicates with them through messaging architecture such as notifier. Each loop is a separate task. Therefore, by separating tasks into different slave loops, we make the application more modular. Master-slave pattern does not need to be created from scratch, but you can use a ready template. To do this, select File, New, From Template, Frameworks, Design Patterns, Master-slave design pattern. In the ready template, we have created a master loop in which instructions are added to the notifier in the case structure. In addition, we have a slave loop waiting for data from the notifier. To demonstrate the master-slave pattern, create a program in which the user will be able to increase or decrease the value of the nominal value of the heating plate. For this purpose, let's create a user interface consisting of two increasing and decreasing buttons and a temperature indicator. Next, modify the master loop by replacing the case structure with the event structure. Let's add appropriate notifier messages depending on the selected button. Let us pass the messages as an enum. Modify the slave loops by adding the case structure. Let's increase or decrease the value passed to the temperature indicator. For this purpose, we will use the shift register, which will store the last value of the set temperature. Let's start the program. We can see that depending on the selected button, the temperature increases or decreases by 1. The master-slave pattern is ideally suited to such cases where the user interface is operated in the master loop and data processing or command sending to connected devices are performed in slave loops. However, the shown pattern has a significant drawback. Let's go back to the previous example with the generation of a sine function. Let's change the representation of the sine function in the chart from line to point. Let's set about 3 times the frequency of the loop generating the sine function compared to the 2 loops in which we read the data. As a reminder, in loop 2, local variables were used to read the generated data, and in loop 3 from the notifier. Let's start the program. We see that on the second and third charts, the sine wave functions have about 3 times less points. Thus, we read every third value. The conclusion is that slave loops must be running more frequently than the master loop.